Alright, we are back at it with the STU, the STU Super Testnet unit. This is Super Testnet's 8-bit CPU for BitVM. If you haven't watched the previous video, I outlined how to use this, how to write assembly commands for it. In this video, I would like to walk you through some interesting things I've found playing with it. So this is the STU, and then this is the program I wrote to help us write some assembly commands and then just copy over to use. So let's start with just a real simple command. We'll load a number. We'll call it, let's just initialize 5 in the register. We'll add it. So here, let me start at the end. We'll just initialize, say, 235 in this data slot in this last byte 15. So I'm going to initialize 5 in the register. I'll add it to the value I have in byte 15. Let's just store it, why not, in a different byte, and then we'll halt the program. So very simple program just to start us off, so I can point out some of the interesting things that are happening in the assembly code. So I'm going to use my own. I'll paste the program here and submit it. So this is what we have, right? We have these commands. The first 4 bits are noting the commands. This is initialize this value in A, LDI, and then the second 4 bits are the value. So we're going to initialize 5. We're going to add to what's in byte 15, and then we're going to store it in byte 14. Then we're going to halt the program. We got no value after the fact, which is fine. Doesn't matter what value you have, as soon as it sees these ones, it halts the program. So we can look at these things as numbers as well, so we can toggle it in decimal display. Those bits add up to 85, 47, 78, 240, 235, and so on. So let's increment the clock slowly. I'll zoom out slightly so we can watch it while it goes. So I'll zoom back in. Maybe this is more helpful for you watching on your small screen on YouTube. So we'll zoom in for this. I'll increment the clock a couple of times. So you see the instruction is LDA 5. We added 5, or we're going to add 5 into the register A. So we got 5 here. Great. We're going to the next command, which is add 15. So we're going to look at byte 15. We're going to take 35, add it to what we have in the register, 240, and so on, right? And then we're going to store it into byte 14, again, so on. And then we're going to get halt. Then 0 is the number here, but we're going to do this. And then after we run through it, up here at the top, we see the computer entered a halt state. So we have halted the computer. What I would like to note here, so obviously this is very simple. We added 235 and 5 and stored it here. In the RAM, there is no difference between what we have in byte 3 here and what we have in byte 14. They're both 240. They both have the same binary display, right? 11110000. And so I was reflecting on this and thought it was interesting. It almost seems like I can do 2 things. I can think of some of these values that I'm storing in memory as potential commands, right? This is potentially a halt command. And then I could also look at some of these commands I've written as as potential values, right? So if I, again, toggle to decimal, right, this command LDI5 also is the number 85. And so I might be able to utilize this space that I have as commands also as memory. So to walk you through how I've been thinking about this, let's change this program, and instead of, so I'm going to take 5, I'm going to add it to 235. We know that that gets 240, which is the halt command. So instead of storing this in value 14, let's just store it in value 3. I'm going to make value 3 say, or byte 3 say nothing. So it should be all zeros. And then I'm curious to store this into, add these up to 240, store it into this byte, and then see whether or not the computer treats it as a halt command, which I expect it to. I actually don't remember if I've tested this or not. I've definitely, I've tested it, I think. So anyway, so we got this. We see it's almost the same command. Obviously, some of these numbers are changed. We don't have a halt command here anymore. We'll walk through the program one step at a time again. LDI 5, excellent. Put 5 in the register. Add 15, excellent. We've got 240 sitting in the register now. We are going to store this value into byte 3. So I'm going to zoom up so we can see. This is going to be byte 3 here, right under the 67, right? It goes 0, 1, 2, 3. So let's increment the clock. Let's see if we can put 240 into that slot. We did indeed. And so now after this command, we should see it reach the next command, which it does, and it is a halt. So I'm going to increment the clock, and the computer is now halted. So we didn't have any halt command in here, but we were able to achieve, we were able to make a halt command, out of adding some of these numbers together. So this is fascinating. I was thinking about taking this to kind of silly levels, and this is a program I had come up with. Let's walk through, let's think about what's going on here. I'll just refresh the page to reset this all. If I do, and this is just kind of funny to say, right, byte 0 is LDA 0. That means the first command is going to be load this data into register A of itself. So it's going to load itself into register A. So again, just really funny to think about. We'll walk through exactly what's going on here. And then I'm going to think about what I want to add here. You'll see this will all make sense in a second here. STA, and then we're going to jump. So I want to add, what are these for? Oh, no, we're staying with add, and then, but I'm going to add 4, and then 4, yeah, and then 5 should make this work. And then we're going to store it in 0, jump to 0. So just from the get-go, the fact that I have jump back to 0, it looks like we're restarting this set of commands. And so we're, this hypothetically is an endless loop, but based on what I have here, we're not going to end up in an endless loop. So we're going to first load what I have stored in slot 0, which is this command. I'm going to add to it what I have stored in slot 4, which is this command. And I'm going to do that twice, and then I'm going to add what I have in slot 5, which is this jump command, right? And then I'm going to store, I've added these all up, I'm going to store it back into 0. So we're going to see this command change after I've added some more things to it. And so we're going to store it in 0, then we're going to jump back to 0, and then we're going to see what happens. So bear with me here. This is exciting to see. So I'll put it in here, reset everything. So LDI, let me toggle it back to, I think the binary is kind of fun to look at because I have a sense of which command is which. So 0001 is LDI, and this preceding 4 more zeros, this is the value 16, as you saw, right? This is, here we have 0010, so this is a 2, these 4 bytes, whatever. These 4 bytes are 1, 2, 2, 2, 4, 6, right? If you want to look at it that way, or, whatever. I'm not counting the other bits, but no, don't think of it that way. This 0001 is LDA, 0010 is add, 0100 is STA, store what I have in registered A into a specific byte, and then 0110, this is jump. So what I'm going to do, right, is I'm going to load itself. It's going to load itself. So, oh, this is fun then with the, I can see LDA 0. So it's going to load itself, which is 16. I'm going to increment the clock. We have 16 in register A. This is great. Next, we're going to add what I have in 4. What do I have in 4? 0, 1, 2, 3, 4. I have 64. So I'm going to add 64 to 16. Great, I got 80. I'm going to do it again. 144. Going to do it now, or now we're going to add what we have in byte 5, which is 96. This is that jump command. Great, 240. We know, hopefully from before, 240 is the halt command, and I'm going to store that back into 0. And so we can see that change here. 0, which was initially 16, is now 240. I'm going to keep incrementing the clock. Now I'm going to jump back to 0. When I do that, I no longer have LDA 0, now I have halt 0. So now we're going to halt the program, and that is great. So it might seem random, but I think this could be useful if you're writing a program. You only have 16 bytes of RAM, and so you can really utilize them to the best of your ability. If you recognize that a command is also a value that you want to use, right, you can load that value, right? If you know, you spend some time doing initializing values with the first few commands that you don't jump back to, right? If I had a loop that kept looping back to if I kept jumping back to command 2 or 3, then I might have a few bytes at the beginning where now I can actually use that as storage after kind of initializing things. Once I'm going through this loop, I can use that as storage and kind of put things back in there. So yeah, kind of fascinating to think about. Might help you like this get some efficiency. Whether I'm reusing bytes or using values as commands or using commands as values, however you want to think about it. So this is one example I thought was fun where I'm really just loading and adding commands together. Another example that I was just thinking about is add and subtract. Add is, the first 4 bytes are 0, 0, 0, 1, 0, and the first 4 bytes of subtract are 0, 0, 1, 1, so they're like off by 1 bit. So how do I want to do this? I want to load, and then I'm going to add, then I'm going to store, then I'm going to jump. So I'm going to load what I have in byte 1. So I'm going to load this value add. No, I'm doing it the other way around. I want to load itself, 16, I like that number. Then I'm going to add what I have in the memory, right? I'm going to add that to this. I'm going to add that to, add whatever value I have in the command. Then I'm going to store that actually back into 1. So I'm going to keep changing this command, and then I'm going to jump back to 0. So this is going to be fun. We'll see how this goes. I'm excited. I haven't tested this one out yet. I just thought about it right before I made this video. So this should be fun to look at. It'd be really funny if I mess this up somehow. Let's see what happens. What I am expecting is that when so I'm going to go through, I'm going to load what I have in 0, which is 16. I'm going to add it to what I have in 1, which is 33 here. Then I'm going to store it back into 1. So we'll see that change to 49. This is great. Just to jump to the binary display, this went from 0010, which is add, to now 0011, which is subtract. And so if I did this right, I probably did this wrong now that I'm thinking about it, but if I did this right, what is going to happen is this is going to keep flipping between, so I'm going to jump back to 0. This should keep flipping between adding and subtracting. So I'm going to load what I have in 0 again, 16. Oh, I already see my mistake. I don't know if you've realized this. This should give me, this gives me way too big of a number. I should have loaded. Would this work here? We're doing this live. If I loaded the value I had in 1 and then I added it to what I had in 0, because I need this LDA to flip things. We'll see if this works. I might keep adding an extra 1. This isn't going to work. I'm going to have to, let's redo this. I'll have to load. Yeah, we'll have to have an extra one in here, but let's make this work. We'll do add. Yeah, because this could be good. So what we're going to do is we are going to, sorry for this delay. In fact, I might jump back to 1, so I'm going to just have this extra LDA because I need that value of 16 in order to make this work. So again, that's why I like having this here. Instead of using a different system to compile, I can just make some changes on the fly and then copy and paste this over. So let's see if this works now. Let's click through. We've got load 0. I don't care about it anyway because it is 16, which is the number I need. I'm going to load what I have in, oh gosh, I get to load what I have in 2. I need to load this add value, and then I'm going to, because this is going to keep switching back and forth. So thanks for bearing with me here. This will be worth it when we see the result, hopefully. So here we go. We are going to LDA 0, whatever, doesn't matter. LDA 2, this is what we want. We want this add 0, this 32. This is great. We're going to add it to 0, which is 48, or which is 16, so we get 48. And now when I'm going to store it back into 2, so now I've got 48 here instead of 32. And so now when I jump back to 1, I am going to, again, load what I have in 2, which is 48. And then when we get to it, great, we are going to subtract what I have in 0. So now I'm going to subtract 16, and now I have 32. I'm going to store it back into byte 2. And so if I auto increment this clock now, we should see I keep alternating between adding and subtracting. So I've got, I don't know, call it a clock if you want, call it a pendulum. This cycle is going to go on forever, but it's going to continue to, change this command that's in the middle of it, this 32 to 48, 48 back to 32, and so on. It's going to keep adding and subtracting. So anyway, just thought this was worth sharing. I thought it was fun to see some of the weird things we can do, just the way that the data is stored in RAM and the way that the commands are stored. You can use commands as values, values as commands, and like this example, change something in the middle of the loop as we're processing it. So anyway, the point of making this video and the previous one is that in the hopes that you watching this will make some interesting functions with this. So please have at it, share any function you've made, anything that you found interesting. I'm sure we'll find it interesting. If you have any trouble or you want to share something, let us know in the comments or join the BitVM Builders Telegram group, which is linked in the description along with these 2 websites. So happy building.